AP Calculus AB. This is office hours for Unit 8, Day 3. These are the even problems. So the rest are odds, so you should check those in back of the book. But here's the few even problems. So pause the video if you need to. Check your answers. Okay, assuming you have done that, let's try these problems. A lot more practice with integration, but also now having to use U-substitution. And at first, they're going to help you out as you get the hang of this. In these problems, it says evaluate the integrals by making the indicated substitution. So they're telling you what the U substitution should be. So number one, part A, 2x, x squared plus 1 to the 23rd, dx, u equals x squared plus 1. So we got to do du equals 2x dx, which is perfect. And so we're going to rewrite it as u to the 23rd du. That's going to be u to the 24th divided by 24 plus c. And your final answer will be x squared plus 1. We've got to change it back to x to the 24th power over 24 plus c. So that's how you do it. It's part A. Part B is cosine to the third power sine x dx. And remember, this is cosine x to the third power. And they're telling you, use u equals cosine x. So du equals negative sine x dx. Don't forget the negative. I don't want the negative, so I'm going to divide by negative 1. So when I rewrite, it's going to be negative. I'm going to put the negative out in front. It's going to be u cubed du. So negative u to the 4th divided by 4 plus c. Final answer would be negative cosine. You can write this like this, but final answer really should be written with that kind of compact way of writing trig to powers. We put it right there. Same thing. I think the parentheses are easier to work with, but that's the way the answers should look. Okay, number 2. Part B. We're skipping part A. So it's going to be the integral of y, square root of 1 plus 2y squared dy. You're being given what u should be. It should be what's inside the square root, which is something hopefully you're starting to recognize what the u is. It's the inner function inside. Du equals 4y dy. There's the y di. Add up with the 4. I'll put the 1/4 in front. That's going to be square root of u du. Now, of course, I'm going to rewrite that as a power. And then we're going to bump it up 1 and then divide by the new exponent plus c. And then final answer be 1/6. 1 plus 2y squared in parentheses to the 3/2 power plus c, of course. And that's your final answer. It's 2b. 2c is the integral of the square root of sine pi theta. And then cosine theta, pi theta, d theta. And they're telling you that you should say u equals sine pi theta. Now, it might make more sense to put parentheses around these. Just make it super clear. But that's the inner function. Makes sense. Du equals, it's going to be cosine pi theta. But then the chain rule says put an extra pi in front times derivative of what's inside, and then you get a d theta. Now, I want cosine pi theta d theta. I don't want the pi, so I'm going to divide the pi to the other side. So when I rewrite it, it's going to be 1 over pi in front. It's just a number. Square root of u du. So it's going to be 1 over pi u to the 1/2 du. It's going to be 1 over pi u to the 3/2 divided by the new exponent multiplied by the reciprocal plus c. Final answer should be written in the original variables. Sine pi theta to the 3/2 plus c. Now, I don't know. I mean, I know I just got done saying that usually with trig, I feel like it might be a little more confusing here, but I guess we could write it right there. It's kind of weird looking. But whatever. Either way. Okay, that's number 2, part C. All right, moving on to number 3, part B. Is the integral of 1 plus sine t to the 9th power cosine t dt. And they're saying that u should be, no surprise, 1 plus sine t. Du would be cosine t dt. Perfect. So we're going to rewrite this. It's going to be u to the 9th du. It's a power rule. Bump it up 1, divide by the new power, plus c. Final answer should be written in the original variables 1 plus sine t in parentheses to the 10th power over 10 plus c. Number 3, part D is integral of x secant squared x squared dx. And they're saying that u should equal x squared. I'm going to rewrite this. Secant x squared squared. Does that make more sense? That looks the same thing. Du equals, and so the x squared's inside. There might be other things inside, but that's for sure inside. Derivative that's going to be 2x dx. I don't want the 2. Easy fix. Put a 1/2 in front. X dx. It's going to be your du. So this is going to be secant u squared du. Now secant squared is the derivative of tangent. And then your final answer should be written in terms of the original variable. So it should be tangent x squared plus c. You put parentheses around there if you want. There you go. All right, number 4, part A is x squared, square root of 1 plus x dx. And they're telling you that u should be 1 plus x. Now, hopefully this is worrying some of you because there's an x squared in front. Like, how are we going to deal with that? Well, du equals 1 dx. If we rewrite this, we can't have any x's. So here's a possibility. We could solve for x in terms of u. X equals u minus 1. Now, I tried this class in the notes, and it didn't really help. But maybe it will help this time. So this is going to be u minus 1 squared, square root of u du. Now what I think we should do, based off of what we've been doing for the last couple assignments, is go and FOIL this out. It's going to be u squared minus 2u plus 1 u to the 1/2 du. And then we can distribute this in and use rules of exponents to get u to the 5/2 minus 2u to the 3/2 plus u to the 1/2. You definitely need these parentheses and definitely need the du. Now I think I got something I could integrate. So it's going to be u to the 7/2, bump it up 1, divide by the new exponent, multiply by the reciprocal. Bump it up 1, divide by the new exponent, or multiply by the reciprocal. Bump it up 1, divide by the new exponent, or multiply by the reciprocal, plus c. And then we got to rewrite it back in terms of x. People are going to forget to do that on your next test. And I'm going to have to take off points. So 1 plus x to 7 halves minus 4 fifths. 1 plus x to the 5 halves plus 2 thirds. 1 plus x to the 3 halves plus c. There you go. 4a. Okay. 5a. So 5a is going to be dx over x natural log of x. And they're telling you you should be natural log of x. Now, a lot of times if you get a rational function, then what's in the denominator should be your u. Maybe not everything, because remember, when you take derivative of this, you should get something that gives you all the rest of the stuff. Look, dx over x, that's exactly what we need. So this is going to be du over u, which is going to be the natural log of the absolute value of u plus c, which is going to be the natural log of the absolute value of the natural log of x. Now, we don't put parentheses around the x. That was already there. The absolute values pop up when you do the antiderivative. Okay. Number 5b. Number 5b, integral of e to the negative 5x dx. So they're saying u should be negative 5x. Looks like the inner function. Du equals negative 5 dx. Don't want the negative 5. So I'm going to get negative 1/5 in front, and it's going to be e to the u du. The antiderivative of e to the u is e to the u plus c. Final answer should be written right back in form of the original variables. This is one that I'd probably do without U-substitution, because the inner function, the only thing that makes it inner function is the extra number multiplying it, which I know is going to pop out in front. So to fix it, I got to divide by it. Boom. Fixed. Done. Okay, number 5, part C, is the integral of sine 3 theta over 1 plus cosine 3 theta d theta. Now, like I said, usually the denominator is probably what's going to be your inner function. All of it, maybe part of it. Du equals, derivative of cosine is negative sine 3 theta. Chain rule says multiply by the extra 3. And of course, we have the d theta. I don't want the negative 3. So I'm going to divide both sides by negative and 3. So we get negative 1/3 in front. And sine 3 theta d theta, that's your du over u. So this is natural log of the absolute value of u plus c. Final answer, negative 1/3. Natural log of the absolute value of 1 plus cosine 3 theta. Now, an interesting thing here is that I'm going to claim this is not the best final answer. If you have absolute values in the answer, you should get rid of them if you can. So like if, for instance, the answer was absolute value negative 5, you'd say it's 5. If the absolute value, 5 was, you'd just say 5, right? You wouldn't leave the absolute values there. Well, think about what's inside these absolute values. Is this always positive or always negative? Because if it's one or the other, we can fix it. This is a cosine function, which only goes down to negative 1, right? Right? And we're going to add 1. So isn't that going to be now the range of this is going to be 0 to 2? We don't need those absolute values. It's always going to be positive. You still need some grouping symbols, like parentheses, but this is the best final answer. On your next test, if you leave those absolute values, I will take off points. If you forget the absolute values and just put parentheses in your work, then I'm going to take off probably even more points. You still got to show the absolute values in your work, okay? 5 part A, we couldn't get rid of those. Natural log is negative. So, and is positive. So you have to leave those absolute values. Okay. Let's do number 7. Now these ones, you're going to get to pick what the u is. But hopefully by now you've had a lot of good practice when they told you what they are. It's usually the inner function. So what looks like it's inside? That should probably be your u, at least what you try first. Du equals negative 2x dx. I need x dx. I don't want the negative 2. Easy fix. Divide by negative 2. Put a negative 1/2 in front. And then you have u cubed du. It's just a power rule. Negative 1/2. Bump it up 1. Divide by the new exponent plus c. Rewrite it without u's in it. 2 minus x squared replaces the u. So that's number 7. Number 9 is cosine 8x dx. So u should probably be the 8x. Like I'm saying, I think I can get away without doing this. Like I would say, oh, well, it's going to be sine 8x, right? And then, but an extra 8 is going to pop out. But I can fix that with a 1/8. Done. Got it. Did it in my head. But until you're feeling very comfortable with it, you could do this. Say, okay, we're going to divide by 8. So that's going to be 1/8 cosine of u du. And then you'll get 1/8 sine u plus c. And then you'll replace the u with 8x. And guess what? You're going to get to my answer here eventually. All right. Number 11. 11 is secant to the 4th tangent. What is it? Secant 4x tangent 4x dx. So in my head, I'm like, well, what's the answer of secant tan? It's secant. It's got to have a 4x inside. It's going to give me an extra 4 in front, which I don't need. So I want a 1/4 here. Done. Right? Wouldn't that work? Check your answer. But we could do U-substitution. U equals 4x. Du equals 4 dx. Don't want the 4. Hey, that's where that 1/4 is coming from. 1/4 secant u tangent u du. So it gives you 1/4 secant u plus c, and then write it back in terms of its original variable. All right, 13. Integral of e to the 2x dx. Again, this is one of those ones where it's just an extra number in the inside. That's easy. I'm going to say it's going to be e to the 2x, but extra 2 is going to pop out that I want, so I can divide by it. Done. Telling you. Or you can use U-substitution. U equals 2x. D equals 2 dx. I don't want the 2. Divide by 2. Rewrite it. 1/2 e to the u du equals 1/2 e to the u plus c. Replace the u with 2x, and look what you got. Same answer I got before. So if it's just an extra number inside, I usually think, I can figure that out in my head. But if it's more complicated, you should use substitution. That's it. Hopefully you're getting good at this.